Hey everybody, in this video we are going to quickly chat about when can you just cross out? When can we just get rid of some operation and its inverse as functions and then just, happily be left with something like x on the inside? And while it seems like we can do that with squaring and square root all the time, the reality is the square root of x squared, the answer is really absolute value of x. A lot of the time they'll say something in the question that x is positive and we could ignore it, but in all reality, it's not always going to be positive, so those absolute value bars will matter. In fact, if you are in a calculus class and you're talking about limits at both infinity and negative infinity, and you have something like x squared in a radical on top and you have just x on bottom, and you're analyzing the limits at infinity and negative infinity or end behavior, you're really looking at absolute value of x over x. So while people might think it's x over x, which is 1, the reality is it's not 1. As you go toward the right or toward positive infinity, yes, it's 1. But as we go toward negative infinity, it's going to be negative 1 that way. So as we go that way, and that has to do with this absolute value. Okay, so, tuck that away, save it for later when you're in calculus and think about it then. When do you use absolute value? Just as a little side point right over here. When you take an even root and the variable that you take out of it, which is an unknown, comes out and has an odd power, you're going to put absolute value bars on it in that case. So how does that tie into this conversation, trig and trig inverse? Well, if I took the square root of something like 7 squared, people are like, okay, I just want to cross out, yaddy yaddy, and I get 7. And is that true? It is true, because 7 squared is 49, and the square root of 49 is in fact 7. However, if I have the square root of negative 7 squared, well, now I cannot just cross out and try to say, right? I cannot just cross out and say, oh, it equals negative 7, right? Like cross out square and square root, la la la, because it's really square root of 49 again. And that answer is 7. And that's where those absolute value bars really start to matter. Okay? So when are we allowed to do this? All right? So let's kind of define a rule here. All right? If we have the f of f inverse of x, right? It will equal x when dot dot dot. All right, when, let's even actually keep that the same. It'll equal x when x is in the range of f of x, the outer function. So when this value is in the range of that function, then we are allowed to just cross them out and say that the answer is x. Now you're probably like, okay, sure, you're saying all this to me, but it still means nothing. So let's go through each case. If I have the sine inverse of the sine of something, I can cross it out and make it equal x if x is between negative pi over 2 and pi over 2, because that is the range of sine inverse. You could look at the little heart chart, and it has to be in that range right there. How about with cosine? Cosine inverse of cosine of x will equal x. I'm going to write it differently this time. If x is between 0, and pi. So that's another way of saying like interval notation with the brackets, but that is the range of cosine inverse function. Okay, that's the range. And again, you can look at the heart chart. Cosine inverse of a positive is between 0 and pi over 2, and cosine inverse of a negative is between pi over 2 and pi. And then I'm just going to do tangent just so I could do these 3 for now. And you could figure out the other ones from there. Tan inverse of tan x will equal x when x is between negative pi over 2 and pi over 2, because again, that will be the range of tan inverse. And you could look at the heart chart to see that. So really, sine and tangent are quite similar in that way. Now, what if it was turned around the other way, right? If it was sine of sine inverse of something, when will that be able to be like, oh, cross it out, right? And then this we said could cross there, and this one here, right? When can I cross those out and say it equals x? Well, then it means x has to be in the range of sine, which is, think of the sine wave, -1 to 1. How about cosine, oops, started writing the wrong one. Cosine of cosine inverse of x will equal x if x is, or let's kind of write it the other way I did before. And also I'm going to just make sure not mixing. Oh, that's a little too squashed. Let's go. There we go. All right. When x is between -1 and 1. And then for tan, if I could fit it on this page, what do we think? Maybe just a smidge. And scooch. Okay. Tan of tan inverse of x equals x. Well, basically, okay, x has to be in the range of tan. But the range of tan is -infinity to infinity. So this is basically, in this case, always, right? Because as long as x is a number between -infinity and infinity, which is any real number, then we're good to go, right? We are good to go. So that is just a breakdown of these cases. It matters about the outer function. The inverse functions have a range that are angles, okay? The non-inverse functions, like regular trig, have a range that is the ratio. What are these ratios? Like opposite over hypotenuse, adjacent over hypotenuse, or opposite over adjacent, and then all of their reciprocals. So I hope this gave you some clarity if you wanted to know when you can do the just crossing out approach. So I didn't even model it, but right there. And again, right there. That's when you can do it, which is not all the time. So be careful, but hopefully that was helpful. So if it was, let me know. If it wasn't, let me know. And that's it. I will see you, or you'll see me, or hear me in the next video. Adios.